In this presentation, I will be presenting about the dataset that I created, which is a dataset about the dimension of cherry tomatoes. This dataset consists of 4 variables, 3 numerical variables, which are diameter, the diameter at which where stem scar is located, and the height of the tomatoes. And the other one is a categorical variable, which is the color of the tomatoes. The diameter at stem car, and height variables are measured using rulers, which actually may cause an error of 0.1 to 0.3 centimeter, while for the color variable is based on what the tomatoes is actually looks. For example, these tomatoes is what red tomatoes looks like. This tomatoes is what orange tomatoes looks like. The reason why I put the tomatoes based on the color or the level of the maturity is because the color of the tomatoes itself cannot be easily described, and also the level of the maturity cannot easily describe. But for orange tomatoes, perhaps it's actually the mix of green colored and red colored into ones. While for the green tomatoes, it only has one color, which is green, like these tomatoes. And the color tomatoes is somehow depends on the maturity, because usually the green color tomatoes is not as mushy as red tomatoes, because red tomatoes is the more matured one, while the green tomatoes is the less matured tomatoes. The aim of this visualization and analysis is to make correlation and determine whether the color of the tomatoes affects the dimension of the tomatoes or not. And also, the aim of this analysis is to understand whether each dimension affects other dimension. The R helps me visualize the analysis better with ggplot and chordplot, etc. So this is the summary of the dataset that I created. Just like what I've said previously, there are 3 numerical variables, which is actually a continuous variables, and 1 categorical variables, which consists of 3 categories: red, green, and orange. Next, this is the overview of the dataset. And yeah, it can be seen that the 3 numerical variables are continuous, while the color variables are nominal data. Okay, so this code is supposed to display the pie chart of the color for each cherry tomatoes. The reason why I displayed this is to understand the percentage of each color. And from this pie chart, it can be seen that the red tomatoes covered about almost 60% of the entire population from the data set, while the green tomatoes have the fewest percentage with 7.8%. Next is the histogram of the dataset. These 3 histograms represent the diameter at which the stem scar is located, the diameter of the tomatoes itself, and the height of the tomatoes. And from these 3 histograms, we can conclude that all of this have a positive skewness. The next code is the code to create a density plot. This is a density plot, and as you can see, this density plot is categorized based on the color of the tomatoes color, for which diameter at stem scar, it is seen that red tomatoes have a pretty normal distribution, and the same things goes with green and orange tomatoes. The density distribution for the tomatoes diameter, it can be seen that the red tomatoes still have normal distribution, and also the orange tomatoes have a normal distribution, while the green tomatoes have a slight of a positively skewed distribution. For the height density, we can see that the red colored tomatoes is somehow have positively skewed distribution, while the other colors of the tomatoes, green and orange, have a positive distribution. From this diagram, we can also tell how spread out the data are, with red being the most spreaded and the green being the less spreaded. The next one is a box plot. This box plot helps me understand better of the distribution for each colored tomatoes and its dimension. So, like for example, in this diagram, we can see that the diameter at stem scar for red tomatoes is somehow positively skewed, while the other color is normally distributed. There's a slight difference between this box plot and the previous density plot. The box plot for the diameters of each colored tomatoes, we can see that the red and orange tomatoes have a normal distribution, while for green tomatoes might have a negative skew. And also from the box plot, we can see that there is an outlier for the diameter of red tomatoes and green tomatoes. The next one is the height for each colored tomatoes, and it can be seen that the height of the red tomatoes have a positively skewed distribution, right? And for the other color, it is normally distributed. Since I can see an outlier from this box plot, I can actually do an action to prevent this outlier from existing. But in fact, after I tried to remove the outlier from the dataset, it resulted another outlier. So it's better to not remove the outlier, because the outlier itself in this case is very genuine, and it also helps me understand the dataset and the visualization of the whole dataset better. Okay, so the next thing that I will be created using this R is the correlation plot, because the correlation plot makes a correlation between numeric variables, while the cherry tomatoes datasets also consists of categorical variables. It is then required for me to set another variables or data name, which is f_num. In this dataset, it only consists of the 3 numerical variables. For the correlation of the fnum dataset, we can see that the correlation between diameter of the tomatoes and height have the strongest correlation coefficient among others. This code visualize the correlation plot of the 3 numerical variables. And from this visualization, we can see that the diameter and the height have the strongest correlation coefficient, and the second highest correlation coefficient is the diameter of the tomatoes and the diameter at which the stem scar is located. And the least strong correlation coefficient is for diameter at stem scar and the height of the tomatoes. The next one is the visualization of Pearce panels. These Pearce panels consist of correlation coefficients for each variables and also the scatter plot. We can see that the correlation coefficient of diameter versus height is 0.83, which indicates a strong positive correlation, while 0.68 and 0.61 coefficient correlations represents moderate positive. The next one is scatter plots, but before visualize the scatter plots, I may have to model the scatter plot. This is the summary of the model of diameter versus diameter at stem scar, which can be seen that it is statistically significant because the p-value here is less than 0, and also the r squared, the adjusted r squared. The same things goes with the model of height versus diameter at stem scar, and the same things goes with the model for height versus diameter. The next thing that I'm going to do is to analyze the scatter plot. Here, as you can see, this is a picture of a scatter plot with its regression line. Just like what we've seen previously, that the diameter and height have the strongest correlation coefficient, which makes sense at this point because the red regression line almost have a slope of 1. And also in the scatter plot, we can see how the data is spread out. The last one is a scatter plot with categorical variables. It is similar to the previous scatter plot, but this time it is categorized into 3 categorical variables, which consist in the dataset, which are the colors of the tomatoes. And with the scatter plot, it helps me visualize and understand better the correlation between the color of the tomatoes and its dimension. It can also be seen that the green tomatoes diameter and diameter at stem scar have a negative strong correlation coefficient, which is negative 0.87. While the other two colors from these diagrams, they have a moderate positive correlation coefficient with 0.67 and 0.33. And for the next diagram, height versus diameter at stem scar, we can see that the height and diameter at stem scar of green tomatoes have moderate negative correlation coefficient. And the height versus diameter at stem scar for orange tomatoes have a weak positive correlation coefficient, while the height for the red tomatoes versus the diameter at stem scar of red tomatoes have a moderate correlation coefficient. And in this diagram, we can see the correlation between height and diameters. For green tomatoes, they have weak positive correlation coefficient. For orange tomatoes, they have moderate correlation coefficient, and for red colored tomatoes, they have strong correlation coefficients. And from each of this diagram, we can conclude that red tomatoes are more spread out and have more varieties. This may be due to the numbers of cherry tomatoes that is measured, because From the previous pie chart, we can see that there are more than 50% of the data set which are red tomatoes, while the other two colored tomatoes only consist of less than 50%. Because the point of the whole visualization and analysis is to understand the dimensions of the tomatoes and how the color affects the dimension or vice versa, and how each dimension affects another dimension, we can conclude that the last mature tomatoes, which is green and orange colored tomatoes, is actually smaller in dimension, while the red colored tomatoes or the more mature tomatoes are more spread it out, which means that the red tomatoes can be small in size or big in size. These results may be due to the few tomatoes that I measured, but overall it could explains me the general view of how each variables of the tomato's dimension and its color depends on other things.